You saw in the keynote, we talked a whole bunch about containers and .NET and all the things you could do there. And I thought I would like to come out and talk about how you can use .NET in Azure. And I've got a couple slides, and we'll do a couple demos as well. So if you have any questions afterwards, obviously we'll do a few Q&As, but feel free to reach out to me on Twitter at @CoolCSH, and I'll answer any questions you have. With that, let's talk about the cloud. This is a diagram we showed a little bit earlier. And this is kind of like if you're building cloud-native applications, here's an array of all the stuff that you have in Azure. And primarily what I work on in Azure is I work on this middle chunk, this app thing. So the team I work on builds web apps, function apps, logic apps, container apps, and static web apps. And I'll drill into those in a little bit. But you can see if you're building a cloud-native application, you might have some messaging. So we have plenty of messaging services. If you're .NET, you might be very familiar with SignalR. We've got a service for that. But we also have service bus, event grids for doing your messaging. Obviously, your cloud-native app needs to have some data with it as well. And so you can see we've got a variety of open source databases, whether it's MySQL, Postgres, Azure SQL, Cosmos DB, if you're looking for that NoSQL kind of thing. And then, of course, if you want to go and monitor your apps, you saw in the keynote as well with Azure Monitor how you can do some of that stuff. But I want to primarily focus on what I call the Azure Application Services. This is where most of your apps should run. As a .NET developer, App Service is a great place of hosting any .NET app, whether it's a .NET Framework app, a .NET 6, .NET 7 application. It's for your full web application. If you have an app running on an IS server locally and you want to move to the cloud, this is your place to go. If you want to build a serverless application where you just write the actual functions and don't really have the app running all the time, Azure Functions is the place to go. Logic apps, that is more of our what we call integration. And that is maybe in the past you had some .NET code that went and looked at some API and some product, and when something came back from that, you went and sent an email, and you wrote a bunch of .NET code to do that. With Logic Apps, you can recreate that whole thing in just a WYSIWYG designer in the browser. And then obviously, as you build your APIs, you want to manage them. We have API management. We have great support in .NET for taking your APIs and publishing them to that. And then I like to think that all of this stuff, our plan is it runs on Azure, and with things like Azure Arc, you'll be able to actually run these on-premise as well. And what I'm going to talk about the most today is Azure Container Apps. One of the things that we hear when we talk to customers today is they want to build apps on top of Kubernetes. Kubernetes is super popular because it's open source, it's vendor neutral, all the clouds support it. So by building apps that run on top of Kubernetes, you can run your app pretty much anywhere. Now, Kubernetes is a great product, and it's got lots of dials and stuff if you want to, but we really think that most of our developers just want to get their apps running in the cloud. So they want to run on Kubernetes, but they don't want to actually manage that Kubernetes. And that's where container apps comes into play. With container apps, you just build your application, put your container up in Azure Container Apps. We're running you on Kubernetes, but you don't have to manage that Kubernetes. So it's like, ignore the infrastructure, just focus on your apps. And it's got all the scalability features and stuff that you'd want and expect from Kubernetes as well. And it's built on a ton of open source tech. So what can you build on Azure Container Apps? Everything. And so if you look here, if you want to be the new cloud native style developer and you're building microservices, it's great for microservices. If you're building public API endpoints, we've talked a lot about APIs today, the capabilities we've been adding in .NET 6 and .NET 7 to make building APIs even simpler. Great place to build public endpoints. Web applications. Yeah, while you can use App Service, if you'd rather run on containers on Kubernetes, you're welcome to run your web app in container apps as well. And then it's great for event-driven processing. So if you look at some of the things like the podcast samples, there's parts of that podcast app, the back end of it, that actually is doing eventing and stuff like that. Great to run in container apps. And then finally, background processing. This is kind of your, hey, I want to wake up every hour and do something. So really, any type of application you have, you can run on container apps if you wish to. Common challenges that we have, even as a .NET developer, that you're going to have, which is, hey, you've got polyglot teams. While .NET is my favorite, many of you might have some Java, you might have some Node, you might have some Python. And so when you're building microservices, how do you make all these things interop? Portability. This is something that think about as I'm developing locally. I might have RabbitMQ on my local machine, but I'm going to use something else in the cloud. How do I do those abstractions so I can run locally with RabbitMQ and then transfer my app to the cloud in Azure using an Azure service to replace RabbitMQ? And so these are some of the common challenges that we have with building these applications. And we have a great open source framework that we recommend for developers that are in that situation. It's called Dapper. And the nice thing about Dapper is it does not require you to rewrite your application. It's a, as I said, open source framework. You can use as much or as little of it as you want to. So for example, as a .NET developer, in many cases, you take your HTTP client factory and you make a few changes to it, you add a single header, and you're Dapper enabled. And then you can use as much Dapper as you want. It will give you things like resiliency automatically. By making that one header change, all your calls go through Dapper, and you're going to get retries. You're going to get easy access to the logs if your APIs are failing, so great observability. And what makes it really cool is on this next slide, we have a ton of these components. There's state stores, there's pub sub brokers, there's bindings and triggers, secret stores, observability. There's a bunch of components that you can actually use in your application. So if you want to, for example, I want to talk to Service Bus. I can write my code to talk to Dapper. Dapper will talk to Service Bus for me, but then I could swap Service Bus out for, say, Redis. And I don't have to make a lot of code changes to do that. And so that's some of the capabilities of Dapper is that getting you away from being tightly bound to the components you build. And as we build these cloud-native applications that you might want to run on-prem and then move to the cloud, it really makes that transportability better. And I really recommend checking it out. .NET 7, that's what we're here to talk about today. We have it everywhere. We have it in Azure App Service in all regions on Windows and Linux. We have it in Azure Static Web Apps for WebAssembly with AOT support. And we have it in Azure Functions. Container Apps doesn't really care what the tech is, but we have all this running in .NET today, in Azure today. So go grab the newest .NET and get it running in the cloud. And there's a couple things that on this slide that are really, I think, important. If you want to go take an application, I mentioned resiliency earlier. When you're in the cloud, maybe it takes 5 milliseconds one time, 100 milliseconds the next time. There's variabilities here. And you can use Poly. We had great support for this back in .NET Core 3 or 3.1, I believe. But there's a URL here. You can go and check out and learn how to make your APIs resilient with Poly. If you want to go run your apps in AKS or Azure Container Apps, because of some of the security features in .NET, we have to configure a secret that we stick somewhere for doing some encryption and decryption. And there's an article here of how to modify your .NET app to support that. And then finally, I've got a link here for Dapper for .NET developers, which will give you a bunch of samples to get started with Dapper. Now, as I said, I wanted to run and do as many demos as I could. And one of the things that people get confused about most of the time is, oh, Scott, do I have to move to .NET 7 if I want to get my application running in Azure? And the answer is no. And so what I want to start off with is I went and I was talking to John Galloway a couple days ago as we're all stressing out about .NET Conf. And we went and took an old application called Music Store. It was a sample tutorial we built back in the .NET Framework 4.0 timeframe using MVC 3.0. And we put a bunch of versions in here. Here's MVC 5. And so I've got an MVC 5 Music Store app right here on my machine. And I can run it. And I have it, you can see right here. It is running .NET Framework 4.8. So it's an old app. And my point here is I want to say, if you want to move your apps to the cloud, you don't have to modernize them to .NET 7. You can move them as they are. We have great support for running ASP.NET web applications, whether they're on .NET Framework or on .NET 7 in the cloud. So here's my Music Store. And once again, we've got, let's run it. There you go. I can log in. I can register. All these great capabilities that we built in MVC way back in the day. And I want to take this app and move it to the cloud. How hard is that? So what I'm going to do here is I'm going to right-click on the application, and I'm going to publish it. We'll go there. We'll select Azure. And it's going to detect that I'm running a .NET Framework 4.8 app, so it's going to offer me App Service Windows. That's where we want to go. And we'll give this a second here to refresh. And it should find my stuff. There we go. And we'll get the Windows folder here. There's my music store. I built one of these before. I don't want to build Azure resources while we're here. And I click that, and we created a publish profile. Now, one of the things that this app has that we should think about is it has databases. So if I go click Connected Services here, you can see I've got 2 databases. I've got a music store entities that contains the actual music store stuff. I've got a default connection that contains my users. And what I've already done is I've already built these databases in the cloud. On my local machine, if I go over here and do SQL Object Explorer, here you can see it right here. You can see the databases for the music store on my local machine. But I've created these in the cloud. And all I've got to do when I do this publish is I have to map those connection strings to the connection string in the cloud. So let's do that right now. So I'm going to go back to this publish page. And all I have to do is scroll down and notice that it knows my connection strings. It knows I've got one called default connection and one called music store entities. You'll see those in my web config here. Here they are. And all I've got to do is click on each of these, and I'm going to say, let's connect this. We'll connect it to an Azure SQL. Make sure I got the right one of these things. That was the default connection. That's my users. So I'll select users. Leave the connection string exactly the same. I need to give it the credentials for my database in the cloud. And I'll say, nope, I don't need any of this. I'll click Finish. What that's going to do is that's going to put my connection string in the environment in my app service. I'll do this again. And this time, always double check which database I'm on. I'm on the entities. That's the main music store. I'll select the same thing. I'll put my credentials in. If I went to my app service, you would see that this action, all it's doing is putting these connection strings in the app service, pointing them at the actual Azure SQL instance. I can click Finish. Done. So that easily. I was able to take my application, make the connection strings point only if I'm running in the cloud to the version in the cloud. And now I can actually just click Publish. And my .NET Framework 4.8 application is going up to the cloud right now. So I do want to make it very clear. You don't have to get your app running on the newest .NET. It works great on any .NET to the cloud. So while we're waiting on that to get published, let's go switch. And I want to show you, it'll take this a second because it's going to go create those databases on the fly using migrations. While we're waiting on that, I want to show you some features that I ran into recently that I sometimes forget about all the cool tech we built. How easy is it to build? And Safia showed a little bit of this earlier today, but I want to drill in a little bit more. I've got a .NET 7 application here, and I'm going to call it Hunter API. And I'm just going to go and add a new folder. So let's go add a folder. We'll call this Models. I'm going to build an API and get it hosted in Azure Container Apps as fast as possible. So let's go and do an add. And I'll add a new item. And I'm going to add a class, and we'll call it Person. And my person's going to have an ID. It's going to have a first name. It's going to have a last name. And it's going to have a title. Great. So I've got my class. Now I need to build it and wrap an API around that while we're doing that. And so let's do this. Let's go into the scaffolder. So let's save this. And what I'm going to do is I'm going to say I want to add a scaffolded item. So we'll go back to add. And we will say add new scaffolded item. Safia showed this morning. It is the API with read-write endpoints using Entity Framework. I'm going to click Add on that. And I will warn people, I'm actually on a pre-release build of Visual Studio today. I was not going to upgrade to the new build this morning and risk stuff not working. So it's going to ask me for an endpoint class. We'll add the endpoint class. It's going to ask me for a context. I'm going to add the context. We want to use OpenAPI and type results. So what's going to happen now is it's going to go add some NuGet packages. It's going to scaffold my API. And I'll warn you right now, once that's done, it's going to cause some errors in this version of Visual Studio. This is fixed. It doesn't happen in the GA build. It's because I'm in a mixed place between working and non-working. But let's let this thing finish generating the code. And then what I'll do is I'll just nuke VS, and we'll close that out real quick. And I'll restart VS, and that'll make this particular error go away. Let's go back. Let's find the Hunter API. As I said, this is because I'm running crazy pre-release builds of the product. So what I've got here is, and IntelliSense is catching up here. It'll take a second. But it generated me this new person endpoints.cs. And inside of here, you can see I've got my map gets for my person, all these things. This is my full API written for me. I didn't write any of that code. Pretty cool. It even took my program.cs and it added a reference to this at the bottom of the app. So as I scaffold these things and it builds my code for me, it automatically puts the endpoint in for me. So if I run the application, I would actually get this. Now let's do something here real quick. We're going to go into data, go into the context, and what I'm going to do is I want to put some seed data in here. So let's just grab this code right here, and we'll put this in here. I'll press save. And what this means is when it creates my database, it's going to go put a bunch of Scotts in. We need some Hunter, Guthrie, and some Handsome in here. So we'll put that in. And let's go run the app. And if I do, I think bad things are going to happen. So let's try getting some people. Let's try it out. And I'm going to guess, wow, lots of exceptions there. So now why did that happen? That happened because, well, I have not created a database. And so we have this really cool feature called Connected Services. And if I click over here, notice it saw that I have a database. It's connected me to a local database. All I've got to do is come over here and say, add a migration. And actually, before I do that, make sure I cancel that out. In the newer version of Visual Studio, we run your app in that in-terminal, but that app was still running, and so I can't add a migration while the app is running. So it'll give a second here. And so remember, I just created that class, I scaffolded, and now it's going to automatically crash for me because that's what it wants to do. Dun, 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 dun. Let's find out why it did that. Oh, I know exactly what that is wrong with. So that's my bad. So I must have messed up my model. But look at that. I made the first name and the last name strings. So let's fix these. It's only real. Now, because I did that, that means I have bigger problems with this application. So let's go nuke the endpoint class. Let's go nuke the, let's go into program CS. Let's nuke the map. I'm going to re-scaffold that because the way I scaffolded that was not good. I scaffolded the wrong class. So let's go nuke the API context here as well. Make sure I don't have anything here that's API context. We'll kill that. And the rest of this should be fine. I'm going to run myself out of time with that error. So what we're going to do is I'm going to cheat. I'm going to start over. So let's go super fast this time. Hunter API 2. So we didn't like the first one. That all looks good. We'll keep that like it is. This is going to cause some fun challenges. You're going to see some more behind the scenes secrets here. So because I'm on a pre-release build, this application's not actually healthy. So let's go fix it. I'm going to swap a package out here. There we go. We'll do a build. There we go. Let's go add this back. How fast can I go? Let's go add the class again. There's the person. Let's not screw the person up this time. Prop int ID. Prop string first name. Prop string last name. And we'll do prop. It knows what I'm doing here, so there's a title. So there we go. We have our first name, our last name, our title. Let's make sure we're good to go. We're good to go. So let's scaffold again. Now we have the classes and stuff all the right way, getting some warnings about nullable. We'll do scaffolded item. Do endpoints using a framework. We do person. We're going to add the new endpoint there. We'll add the context there, open API, add. We will then blow up Visual Studio one final time. And then I'll launch and relaunch, and we'll be good to go. I said you won't see this because you're running the production version, not the crazy mid version I'm running from last weekend. There we go. Let's open Hunter API 2. And now what I was going to miss last time is if I, now we got our code created again. Let's go back to data. I want to go add that sample data that I had. There it is. How fast can I go? We can get this thing to the cloud in the next 3 minutes. I know I can. So there we go. I've got my seed data here. And now, if I ran the app, it would fail. But I go, again, to connected services. I've got a database here. It's connected. Now I can right-click here, and I can say Add a Migration. And this might be new to you, knowing we have these tools. You just click in the tool. We find your database. We bring it right up here. I click Finish. It's going to go make the migration. It's going to have all the code to create my database, create the code inside my database. Good to go. Now I'm going to go and say Update Database. That's going to go take that migration, run it against my actual application. I'm going to eat into 1 minute of my QA time here, so sorry, folks. Database upgrade with migrations. Now that means if I run the application, I've now got a fully running API. It'll return data. Good to go. Try it out. Execute. There we go. There's my people. You see that working. So we've got a fully working application here. Now, as we talked about in the keynote, we want to run this as a container, but I don't have Docker installed. I have none of that stuff. What do I have to do? This is just temporary as well. As we get closer to some of the earlier previews coming out, we're going to make this tooling a little better. You jump out of here. Hunter API 2. There we go. Let's go enter Hunter API. And I'm just going to add this one package. This is the package that lets .NET build containers. Boom. So I'm good to go. And what else I can do, what I can also do as well is let's go in and let's create a Git repository. I want this to have CI/CD, all that kind of good stuff. Hunter API 2, private repository looks good. So there we go. So now we have our app in Git. I've got my databases. I've got all this stuff ready to go. I've added my package for container publish. Let's go right-click. We'll do a publish. I'm going to select Azure. Click Next. Now I've got App Service Linux that shows up because it knows that I'm a Linux application. Normally, we would require adding Docker support, adding a Docker desktop. I don't have to do any of that stuff. It's going to go out there and query the cloud. There it is. There's my instance in the cloud. It needs a registry. I made one of those. That's what containers need. Now notice I have this option. This is the new options, SDK or Docker desktop. I'm going to choose SDK. And then I can also decide just to do a publish, or because I'm actually in GitHub, I can actually do actions. We'll actually build our container in the cloud using the SDK to do that. I'm just going to do this to go as fast as possible. I'll click publish, and the app's going to go up into the cloud with no Docker on the machine, whatnot. I've only stolen 1 minute of QA time, and so I will hand it over to you folks for questions.